Okay, for the first problem, we're trying to find the slope of the line passing through each of the points below. So the first thing I'm going to do is draw a quick sketch. So if I've got 2 points, I've got 1, 2, and 4, -1. And I know that there's a line that goes through those like that. And then if I draw my slope triangle, to go from 2 to -1, that's a distance of 3, -3. And to go from 1 to 4, that's a distance of +3. So the slope is -3/3, which is -1. I'm going to do the same thing for the second problem. I've got 7, 3, and 5, 4. Draw my lines. This is 7, 3, and 5, 4. Draw my triangle. The difference between 4 and 3 is -1. The difference between 7 and 5 is 2. So the slope is -1/2. Next one, I've got -6, 8. That's up here. -6, 8. And -8, 5 is right here. Oh, sorry, that's further this way. This is a bad sketch. I've got -6, 8. And -8, 5. So if I draw my triangle, the height difference between 8 and 5 is 3. And the difference between -8 and -6 is 2. So my slope is 3/2. Alright, and the last one, I'm noticing that I'm finding the difference between the height and the difference between the length of each triangle. So I'm going to do here the difference between the heights is 67 minus 68. And the difference, so this is the change in y over the change in x. The change in x is 55 to 50. So this would be -1 over 55 minus 50 is 5. So my slope is -1/5. Alright, match the following graphs with their linear equations. Pay special attention to the scaling of each set of axes. Explain how you knew it was a match. So let's see. First, I know that this graph has a y-intercept of +4. So it's either this one, that one. Oh, they all have a y-intercept of +4. I see that now. So that doesn't really help me. I need to pay attention to the slope. Well, let's see. I know that one of these slopes is negative, and that this one's going down, so D has to go here because the slope is negative. Explanation, I know it has a negative slope. Okay, so the next one, let's look at this one. I'm going to calculate the slope by drawing a triangle. So I go over 2. 1, 2, 3, 4. Yeah, I go over 2 and I go up 1, 2, 3, 4. So my slope is 4/2, which is 2. So that's going to be C. Explanation, I found that the slope is 2. Alright, now these are a little bit trickier because the scaling is different. The scaling is by 2's. So if I draw a slope triangle, I go 2, 4, 6, 8, and I'm going up 2, 4, 6, 8, so I'm going up 2. So my slope is 2/8, which is 1/4. So that's going to be A, because my slope is 1/4. So I found that the slope is 1/4. So then the last one must be B. but I'm just going to double check. So this time my x-axis is going by 2's and my y-axis is going by 4's. So I've got a point right here. I go over 2, 4, 6, 8, and I go up 4. So my slope is 4 over 8, which is 1/2. Good. B has a slope of 1/2. So here my explanation really was process of elimination. But the slope is correct. All right, diamond problems. So I need two numbers that add to make 10. So 11 plus -1 is 10. 11 times -1 is -11. 5 times -3 is -15. 5 plus -3 is 2. I need to find a number that multiplies by 2/3 to make 1. So remember, when you multiply by numbers, you multiply across. So 6 over 6 equals 1. So I need to multiply by 3 over 2. When I add 2/3 plus 3 over 2, I'm going to get a common denominator of 6. So I'm going to multiply 2/3 times 2 over 2 and get 4 over 6 plus 9 over 6, which is 13 over 6. Two numbers that multiply to make -14 and add to make -5 are -7 and 2. All right, we've got Dean and Carlos, and they are holding their own race. Dean estimates that he rides 3 meters every 4 seconds and wants a 5-meter head start. So I'm going to go ahead and graph Dean. So let's see, this is time, and this is distance. So 1, 2, 3, 4, 5 seconds. 1, 2, 3, 4, 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, and that's 10. So Dean estimates he rides 3 meters every 4 seconds and wants a 5-meter head start. So Dean starts right here at 5, and he rides up 3 meters, 1, 2, 3, and over 4 seconds. 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. So this is Dean. So if he rides 3 meters every 4 seconds, that means every 1 second, 0.75 meters per second, because you just divide. You just divide 3 meters by 4 seconds to get how many meters he rides in 1 second. And you can see that right here. If we draw a teeny tiny slope triangle, if he goes over 1 second, he goes up 0.75. All right, and Dean's equation is y equals 3 over 4x plus 5. Carlos rides 1 meter per second, and he doesn't get a head start. So he starts at 0, and he goes up like this. So I'll just have Carlos's line be this series of dots. So that's y equals, his slope is 1 over 1, so just 1, x plus 0. Or you could just say y equals x. At one time, will Carlos and Dean be the same distance away from the starting line? So it looks like Dean is going up 1, 2, 3 over 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. So Dean's line should go through that point right there. And Carlos's line also goes through that point. So this point right here, this is Carlos. This point is where they intersect. So that's where they cross. So they are the same distance away. 1, 2, 3, 4, 5. That's 15. 1, 2, 3, 4, 5. 20. 15, 1, 2, 3, 4, 5, 20. They are 20 meters away in 20 seconds. So you need to use complete sentences there, and your mathematical evidence should be this graph right here. You should show that intersection point on your graph to show mathematical evidence.